distillation apparatus. So it's actually quite a tricky one to set up. The reality of the situation, you might actually not actually get the correct setup. But this is how it looks at the moment. And what I'm hoping to do is I'm hoping to separate out the solvent in this mixture over here. This is coloured water. I'm going to separate out the solvent and allow it to rise up here, and as a gas, if it boils, then it's a good sign that it's actually starting to go. When it rises up here as a gas vapor, we'll be able to check off the temperature. So we'll be able to take a reading. And now it's water, so I'm hoping to get 100 degrees or near enough. And then what will happen is the vapors will pass through here. This part of the apparatus is called a Liebig condenser. It actually contains a tube that's on the inside, surrounded by a jacket, where water comes in through here, flows up, and then flows out again. Once we have that set up, we'll be able to turn that vapor into droplets of liquid, and I'm hoping we're going to start to have some droplets of liquid form in this very dry beaker. Okay, so all of that just to get a little bit of water down. I'm going to start off the condenser, just have a look and see how the water flows up while everything's heating up. So you see that? You can actually see, check out these air bubbles that are naturally coming from the tap. This is just connected to a sink over here. So the piping is just going around here. This is cold water coming through here. And where my stick is, that is actually not in contact with any of the water. Where my stick is a tube connected to this original apparatus here. So we've just got a little tiny Bunsen over here, heating away, trying to spread the heat around here, bringing up to a point where this will start to boil. Just going to turn it up a little bit. It'll take time. It's fine. Coming back over here while we're waiting. So cold water will come over here and it will actually warm up because the hot vapors coming through will touch the inner walls of this Liebig condenser. And once it does that, the heat is transferred from the gas particles to the liquid water particles that are zooming up here. So the water in this water jacket, this Liebig condenser, will start to warm up, and then warm water will then flow out of the top, and then it will just flow in the sink over here. So the reason why we put warm water, or we allow warm water to come out from here and not here, is because we want to let gravity fill this up rather than allow gravity to pull the water down just to the bottom of this condenser. If that was to happen, then what would happen would be that you would not have any surface at the top exposed. I'm good, thank you. I'm videoing right now. Just, could you do me a favour and close the door, thanks? Thank you. So what you can actually have is you can actually have warm water coming out from here, going through here, and we don't have the cold water coming through here, otherwise the hot surfaces over here and here would not be cooled. There would not be anything to cool that down. Right, okay, sorry about that. So we're working a live school. So this is very promising. Now, inside here, just for completion, I actually have some anti-bumping granules. Now, anti-bumping granules allow us, let's zoom in, to start the bubbling and the boiling from one position, so it's not going to jostle around everywhere. Okay. So I've actually got some anti-bumping granules here. While you're watching that, Turn your balance. So everything is now happening right now. The temperature is bubbling, but let me just show you these anti-bumping granules. That's what they look like. And so we actually have those in there. Right, okay, so it's all happening now. I'm just going to turn the heat down a little bit. So go half open, half closed. Now, what's actually happening here is the following. So this mixture is now heated up to the boiling point of the water itself. The water will boil, and this colour here has actually been selected because it actually has a higher boiling point than the water. So the coloured substance is actually going to stay behind. You can actually see that there is condensation on the inside over here, but what we want to do is we want to try and heat this in such a way that all of the inside surface is above 100 degrees centigrade. We don't want to have any surface on the inside at too cold a temperature. So we need to keep heating it, and the reason why is because we want to try and force the vapor up through here. Now you can see that this has now started to fill with condensation. So this area over here is starting to condense the water that has bubbled from here. Now what we want to do is we want to keep this warm, and if I just have a look at the thermometer reading over here, it's now fast approaching 100 degrees. At the moment it is roughly around about 92, but that will reach 100 degrees. Now you'll notice on the inside here that there is a dripping of the water, and that will collect on there, and it should drip down. Just going to give it a tiny nudge. You saw that it actually dripped down. So what's happening is that the vapor is coming up here and it's condensing here, and at the point where it's condensing, that is actually the boiling point of the water, because water boils at the same temperature, 100 degrees centigrade, as it condenses. So this is now fast approaching 100 degrees. Now what I've got over here is the condensation. Now this is cold surface, and now this is very, very cold, and it's being maintained that way because the cold water is coming through here and the warm water is going out there. Why is it warm? Because the vapors are coming through here. The vapors touch the inside cold layer, and the vapor loses energy. It transfers energy into the water that's flowing constantly past, and as it loses energy, it's going to condense down. It's losing energy. The particles lose energy, and they come together and they reform the liquid. And now hopefully we'll be able to see some of the liquid dripping down through this area here. So we're just going to wait. Let's see if I've got any water already. Not just yet. We're just hoping to be able to show that. Just be very patient. I'll put the heat up again. Oh, there's something coming through. I think I saw something coming through, but let's just have a look. Ah, here we go. Here we go. And that's the exciting part. This bit over here, there is a colourless, transparent droplet of water, and that's now going to fall into my beaker, so I'll be able to get pure water that way. It's amazing. Okay. So to summarise, a couple of things I'm going to summarise. First of all, the water starts off as a liquid here. It turns into a gas. The gas keeps rising because the inside is too hot for the gas to settle and condense on the inner layer. As it condenses on the thermometer bulb, that thermometer reaches all the way up to 100 degrees centigrade. The vapors continue to travel through to this point here, and as they pass through the Liebig condenser, the vapors touch the inside of this condenser, sort of glass wall, so the vapors are passing all the way through here, and they touch the inside wall, and that inside wall, that inside layer is cold because you're constantly pumping water from this end here to this end here. The water on the outside, that's in the condenser, will warm up, but the vapor, the water vapor that's passing through the inside here will cool down. And as it cools down, it goes below the boiling point of water, so it turns into a liquid. See, the vapors have to be above the boiling point. So all these gas vapors are well above 100 degrees centigrade. And it flows through here, goes all the way through here, condenses as a liquid, and now we have plenty of water now collecting and dripping down into my collection here. And there we go. Can you see that water? Just hold this up so you can see we have liquid water, and it's not green, so the separation has succeeded. There we go.